Hi everyone, we are from Master of Science in Finance program. Today, I and my colleague will talk about how to price options by using our program. We will start with Black-Scholes option pricing model, followed by 3 exotic options. We will use our program to price these options. I will introduce a little bit about our program. There are 4 windows: code writing, result, environment, plots and reference. We can use code writing window for writing codes, then click run here, or you just press Ctrl and Enter to see the result in the result window. The environment window stores the values of each variable. Plots and reference we mainly use for looking at help menu. When you open our program, firstly, you have to install the packages for option pricing. They are F options and F exotic options. You can also install the library to see the help menu. Okay, so I'll run the installation. I think the installation is finished. In order to price an option, there are key variables you need to know. But if you can't remember, we have a helper. You just type $GBS option, generalize Black-Scholes options, and then click run. So here, in this window, you can see the definition of the function, the usage, and also the key variables here. You can read through it whenever you want. Okay, so now I will give you the example of how to price a call option and put option. You can see many variables that we have to put in. Type flag. C is for call option, and this P is for put option. S is the current price asset. X is the exercise price. T is time, the time to maturity measured in years. If T equal to 1 means 1 year, but here in this example 0.5, it's 6 months. R is the annualized rate of interest used for compounding, and B is the annualized cost of carry rate or dividend rate. And the last one, sigma, is the annualized volatility of the underlying asset. Here 0.25 means 25% volatility per annum. Okay, after we put all the relevant variables, next step is to create a new variable using function GBS option. Here, the name of the variable is call price. So because we price the call option, so I will use call price here. And then we'll type GBS option followed by type flag S, X, time, R, B, and sigma. And then to specify that we want the price, we'll put assign and then price here. Oops. Okay, and then I'll click run. In the environment window, you can see all the variables that we have input, and the call price is 13.83. Okay, for the put option, here we have exactly the same constraint, but we change to put option pricing instead. So I create the variable name as put price, and then I'll use exactly the same function here as the core option, except type flag is put, and I'll execute here. Click run. Okay. Here we have put price, which is 5.74 here.
Okay, next we will show you how to price an exotic option, which we will use barrier option as an example. Barrier options are options which is valued depending on whether the price of the underlying asset reaches the specified level called the barrier. Today we will discuss three types of barrier option. First, the single barrier option. Second, double barrier option. And the last, the discrete barrier option. To make you guys see the picture what are we going to talk about, we will explain those options from the graph. From this graph is down and out call option. To price this option, we will show you how to use our program to price it. We will use CDO or down out call as an example. Here's from the R program. We type the type flag CDO as I mentioned before, and S stock price is equal to 100, X is 90, H is 95, K is 0, time we type 0.5, R 0.08, and B 0.04. The sigma or volatility we set it equal to 0.25. To price it, we just we drag it off these data and then click the button run. Here's the result. On the top right, it will show that the price of CDO is equal to 6.74. You can change the type of the option by change type flag here from CDO to CDI, which denote to a down and in call, or CUI, up and in call, or CUO, which means up and out call. Similarly, the type flag or the corresponding puts are PDI, PUI, PDO, and PUO respectively. Do you guys know that the sum of the knock-in call option and knock-out call option with the same strike price and barrier will equal to the price of plain vanilla call option? This can be applied to put option too. Let us prove it to you. Previously, we have priced the COO which equal to 0.74. This time we will price the CDI with the same strike price and barrier. From the R option, from the R program, I type the trifecta CDI and with the same data set as previously, and then we're gonna drag it all and hit the bottom run. From the top right, we show the price is equal to 7.08. If we sum the CDI and CDO, the 7 plus the 6, the price will equal to 13.83 as we priced before with the Black-Scholes model. Next, we're going to talk about the double barrier. For the double barrier option, it's either knock in or knock out if the asset price touches the lower or upper barrier. Here, the lower barrier, and here is upper barrier during the lifetime. Once a barrier is crossed, the option comes into existence if it is a knock-in barrier or become worthless if it is a knock-out barrier. In this case, we will use CI or up and in down call as an example. To price it, we use the R program. And here, type the trifect CI and the S equal to 100, X 95, L 90. U is mean the upper barrier and L is mean lower barrier. Here, to price it, we drag it off the data and hit the button run. And here's the result. The CI, the price is equal to 10.567. Okay, and for the last option that we're gonna show you is the discrete barrier option. Discrete barrier option is one type of barrier option in which the barrier level is only monitored discretely at specific date, rather than continuously. From this example, the time that we monitor discretely is 0.5. To price this option using R program, we use this function. And again, to price this, we drag all of it and then hit the run button. Here is the result. The price of this option is equal to 109. And this is an example how to price options with R program. Thank you for watching.